Hey, this is Mike. This video is part of a series I call One Step Back, Two Steps Forward, where I will talk about some super fundamental concepts in maths. It's my strong belief that we need to get the fundamentals right before being able to move to the next level. For this video, if you struggle at converting units at any level of maths or applications of maths, you are at the right place. To give you a glimpse of what you're going to learn, here is the rundown. We will learn how to convert one-dimensional unit like kilometer to centimeter, and then move on to higher dimensional units like meter cube to centimeter cube. We will also look at how to convert compound units like meter per second to kilometer per hour. In the end, I'll make a discussion and talk about some of the more advanced use cases of units, and hopefully you will have more appreciation for this often ignored aspect of maths. To make sure we are on the same page while going through the later part of this video, let's review two basic rules for operations with units. Rule number one, we can only add or subtract quantities of interchangeable units. For example, when we do maths about length, we can definitely add 1 centimeter to 2 centimeter or subtract 1 centimeter from 2 centimeter. You should also know that we can add 1 meter to 2 centimeter because meter and centimeter are interchangeable. However, we can never add or subtract quantities that are not interchangeable, such as length and weight. Rule number two, when we multiply or divide quantities, we evaluate the units like what we do with numbers. It's best to illustrate that with examples. First, when we multiply 3 meter with 3 meter, 3 times 3 is 3 square. Likewise, meter times meter is meter square. Next, when we divide quantities, identical units can be simplified like numbers. Therefore, when we divide 10 meters square by 5 meter, meter square and meter are simplified into just meter. As for the last example, the rules stay the same. When we look at the numerator, meter and kilogram multiply to kilogram meter, while second and meter in the denominator multiply to second meter. In the end, 2 meter units are effectively cancelled. Now that we know the rules, we can see how one-dimensional units are converted. In a nutshell, we only need a pair of equivalent quantities. For example, if you want to convert between centimeter and meter, we can use the fact that 100 centimeter is equal to 1 meter, or 200 centimeter is equal to 2 meter. The choice doesn't matter as long as they are equivalent. Say we want to convert 47 centimeter into meter. We just need to multiply that with 1 meter over 100 centimeter. Why? Because the rules say when the unit centimeter is divided by another unit centimeter, they are simplified and effectively cancelled. This way, the unit is converted to meter and we get 0.47 meter. If you're wondering, what if you messed up and do the reverse? Let's see what happens. If we actually multiply 47 centimeter by 100 centimeter over 1 meter, in the numerator, the unit becomes centimeter square, while in the denominator, we have meter. This unit centimeter square over meter makes no sense at all, and we know that we have made a mistake. We can then do the reverse to correct ourselves. Let's see more examples. Some of you might not have realized currency is actually a unit. For example, 1 British pound is equal to 1.37 US dollar. So how much British pound do we get if we convert 50 US dollar? We just need to multiply 50 US dollar with 1 British pound over 1.37 US dollar. Then we will get 36.5 British pound. Do you know Michael Jordan? Arguably the best basketball player ever. We know that he is 6 foot 6 inch tall. That is 6.5 feet or 198 centimeter. How can we use this information to convert 175 centimeter into feet? It's not much different from previous examples. We just need to multiply 175 centimeter by 6.5 feet over 198 centimeter, and we will get 5.74 feet. The last one-dimensional example is very common in textbook. Say you're reading a map that has a scale of 1 to 2 million. Our route is measured to be 2 centimeter on the map. What is the real-world distance in kilometer? First, because of the scale, we need to multiply 2 centimeter by 2 million to get 4 million centimeter. I know that a lot of students don't know how to convert directly between centimeter and kilometer. It doesn't matter because what we have just learned can be applied in succession. First, we may convert centimeter to meter by multiplying 4 million centimeter by 1 meter over 100 centimeter. We will get 40,000 meter. Next, we multiply that by 1 kilometer over 1,000 meter to get 40 kilometer. This example shows us how versatile this technique is. If you understand the last example, you will have an easy time learning how to convert two-dimensional units. For example, if you want to convert between centimeter square and meter square, you can either use the fact that 100 centimeter is equal to 1 meter, or 10,000 centimeters square is equal to 1 meter square. The choice is yours. Let's see both in action. If you don't know what 1 meter square is in centimeter square, it is fine. In our example, when we convert 0.5 meter square to centimeter square, we multiply 100 centimeter over 1 meter twice. The unit meter square on the numerator and the denominator are effectively cancelled, and we can get the answer 5,000 centimeters square. Of course, if you do remember 1 meter square is equal to 10,000 centimeters square, the conversion will be even more straightforward. At this point, I believe we can go over how to convert three-dimensional units like centimeter cube to meter cube quickly. In this example, we want to convert 500,000 centimeter cube into meter cube. We only need to multiply that by 1 meter over 100 centimeter 3 times. If you're familiar with the index notation, you may just start with the second I. It's more concise. In the end, we will get the answer 0.5 meter cube. Sometimes we will be dealing with units that are more complex because there are several units put together. I call them compound units. Some of the more common ones are meter per second and kilometer per hour. They are both speed, and let's try to convert between them. For example, Usain Bolt has a speed of 10.44 meter per second in a 100-meter race. What is his speed in kilometer per hour? To do this, first, we convert meter into kilometer by using the fact that 1 kilometer is 1,000 meter. After that, we will convert second into hour using the fact that 1 hour is 3,600 seconds. In the end, we know his speed is 37.584 kilometer per hour. I'll show you one more example that is highly relevant to students who study chemistry. Sometimes we might have to convert units like density in gram per centimeter cube to molarity in mole per dm cube. If you don't know what they are, don't worry, because we will see in a minute that the conversion is nothing special compared to the previous examples. Say we want to convert the density of NaOH, which is 0.025 gram per centimeter cube, into molarity. First, 1 dm is 10 cm. So we will convert centimeter cube into dm cube. Next, we'll use the fact that 1 mole of NaOH is 40 gram to convert gram into mole. In the end, we'll see that the molarity is 0.625 mole per dm cube. I wanted to make this video not only because students are asked to convert units in exams. If you pay attention to them, you might find usages that you might have never thought of. Let's see 2 examples. When I was doing A-level physics and engineering in the university, I was dealing with a lot of quantities that are really complex. Sometimes remembering their units could be difficult. I'll use a relatively easy one to illustrate the idea. In physics, there is a quantity called momentum, which can be found by multiplying mass with velocity. Since the unit of mass is kilogram, and that of velocity is meter per second, they multiply to become kilogram meter per second. That way, we automatically know the unit without memorizing, because for any formula or equation, not only the amount is equal on both sides, the unit must match. Imagine this. There are only a few fundamental units in maths and science. If we know how they are combined, we will be able to derive any other compound units that we come across. The second use case for units is immensely valuable for students taking exams. There will be times when you must memorize some formulae. Units can allow you to make sense of a formula and identify potential mistakes that you have made. Say you have memorized the formula for total surface area of a cylinder and come up with this. How can we do a quick and dirty check that this at least makes sense? Units can help you. In the formula, 2 pi has no unit. We can ignore them. As for r squared, the units should be square of a length unit. We will assume this is centimeter square. On the other hand, h is the height of the cylinder, so its unit should be centimeter. What happens then is the unit of the first term is centimeter square, while that of the second term is centimeter cube. Remember, only interchangeable units can be added. That means this formula is wrong, and you have to go back to revise it. There are other creative uses of units, but I can't cover all of them. I hope you will gain an appreciation of these unassuming units. They are not really meant to burden you, but to help you. As always, thank you very much for watching. Please like and subscribe for more maths content and study tips in general. See you soon.